All right, let's dive right in. We're going to pull back the curtain on the protocols that are literally the lifeblood of enterprise networks and the internet itself. We're talking OSPF, BGP, and the real magic trick, making them actually work together.
So here's the game plan. First, we're going to look at how your network finds its way around internally using OSPF. Then we'll zoom out and see how it connects to the rest of the world with BGP. After that, we'll figure out how to build the bridge between those two worlds. And finally, we'll wrap up with the big choices a network designer has to make.
Okay, let's start from the inside and work our way out. Before a single piece of your data can even think about hitting the internet, it has to know how to get around its own home turf. And that's the first big challenge, internal routing.
Just picture it, a huge corporate campus, right? Dozens of buildings, thousands of devices, all buzzing with activity. How does an email from the finance department find the printer way over in marketing, and how does it do it like that? That's the first puzzle every single network designer has to solve.
And the answer, most of the time, is a protocol called OSPF. It's an interior gateway protocol, an IGP, which basically means its entire universe is inside your company's network. You can just think of it as a super smart, hyper-efficient internal GPS for all your local traffic.
So what makes OSPF so good at its job? Well, first off, it's a link state protocol. That means every router has a complete map of the entire network, no asking for directions needed. Its hierarchical design is absolutely perfect for big, sprawling enterprise networks. It's also got this thing called fast convergence, which means if a cable gets unplugged, it adapts almost instantly. And of course, it's secure, keeping that internal map safe from anyone who shouldn't be messing with it.
Okay, so we've got our internal navigation totally locked down. Now it's time to open the front door and connect to the millions upon millions of other networks out there that make up the internet.
This is a whole different world. At the edge of the internet, it's not just about finding the fastest path anymore. Now it's about policies and contracts and navigating this massive global web of different service providers. The trusty GPS that works so well inside just isn't built for this kind of journey.
For a job this huge, we need BGP. It is the protocol, the only exterior gateway protocol that runs the entire internet. BGP couldn't care less about the fastest way to get across town. What it cares about is the right way to get a letter from a post office in New York to one in Tokyo, following all the rules and agreements between countries along the path.
And this slide right here, it just nails the core difference. Think of it this way. OSPF is your local courier service, totally obsessed with finding the quickest route across the city. BGP is the International Postal Union, focused on the official rules and policies for moving packages between countries. They both route stuff, but they are solving completely different problems on a totally different scale.
So we've got our internal GPS and the global postal service. But here's the catch. They speak different languages and they have totally different priorities. So how in the world do we get them to talk to each other so a packet can actually get from a computer inside our company out into the wild?
This is where the real art of route manipulation comes in. It's this critical translation service that has to happen right at the border of your network. It takes all the internal street addresses from your OSPF-powered GPS and formats them in a way that the BGP-powered global postal service can understand, so it knows where to send the return mail.
The key to this whole translation thing is a process called route redistribution. It's literally the process of teaching one protocol about the routes that the other one knows. This is how your private little network announces its existence to the entire internet. It's a pretty big deal.
It boils down to this really simple but incredibly powerful three-step process. First, the router at the edge of your network learns all the internal paths from OSPF. Second, it translates them into the language of BGP. And third, it advertises them out to your internet provider, which effectively puts your network on the global map.
But redistribution isn't your only tool. What if you need to bend the rules a little? Well, that's where policy-based routing, or PBR, comes in. This lets a network designer act like a traffic cop with a manual override. They can ignore the standard route and force traffic, say, from your supercritical servers down a more expensive but more reliable path just because the business needs it.
Okay, let's pull all this together. Because, understanding these tools is one thing, but actually applying them is what separates a network that just works from a network that's truly great. It all comes down to the designer's choice. This table, right here, is basically the essential cheat sheet for any network designer. And the big takeaway is that these tools are not interchangeable. You have to use the right tool for the right job. OSPF for speed inside,
BGP for policy outside, and then using redistribution and PBR to act as the smart controls between them, that is the core skill you need to build a network that's strong, scalable, and intelligent.
And that's our deep dive into the world of OSPF, BGP, and route manipulation. Now, these protocols have been the absolute bedrock of networking for decades. But with automation and software-defined networking becoming a bigger and bigger deal, you have to wonder, what happens next? It leaves us with a pretty fascinating question about the future, doesn't it?